In this lesson, what we're going to talk about here in this first part is writing chemical formulas, and specifically ones that only involve two elements. And then in our next lesson, what we will do is we will actually write or learn about writing chemical formulas that involve something called a polyatomic ion. So first of all, let's kind of do some review. And this is a good review in general for your bonding. So if you have a problem remembering the types of bonds, this is actually a little bit helpful. Remember, if I have a metal plus a nonmetal, that's ionic. If I involve that polyatomic ion, which I know we haven't talked about yet, but it's one of those I'm previewing type of things, it would also be ionic. And if I have a nonmetal plus a nonmetal, I would write the formula covalently. We're going to deal with ionic and covalent today, the metal plus nonmetal and the nonmetal plus nonmetal. We'll deal with the polyatomics in the next lesson. Alright, so with ionic formulas, how do I write them? Well, there's a couple of rules first. First of all, I always write the symbol for the metal first, followed by the symbol for the nonmetal. So for our example, we're going to be using magnesium and chlorine. So I would write the Mg first and the Cl second. Then what I do is I write the superscript representing the oxidation number of each element. So if I look at magnesium, it's in group 2. Okay, and we talked about that one before. Since it's in group 2, it has 2 valence electrons, and since it's an ionic compound, it wants to give those up. So its oxidation number is +2. Chlorine is in group 17, and since it has 7 valence electrons, it wants to gain 1 in order to be stable, and so its oxidation number is -1. Now, if we're starting with the elements and not a formula, this is kind of what we're trying to do here. In order to go ahead then and write the formula, we have to ensure that the charges or the oxidation numbers total up to 0. And the easiest way to do this is something called the crisscross method. So we're going to stick with our example here of magnesium and chlorine. So just very briefly, and you don't have to necessarily write this, all we really need are the symbols with their oxidation numbers. Okay, so remember, we've got magnesium with its 2 valence electrons, so that gives it an oxidation number of +2. And we have chlorine with its 7 valence electrons, which gives it an oxidation number of a -1, because remember, it wants to gain 1. Alright, so this is where we're at. We've got magnesium with our +2 and chlorine with our -1. Now what we do is we crisscross. And when we crisscross, you only take the number. The sign does not show up. So let me show you what I mean. You're going to take that 2, and that 2 is going to drop down and cross over and become the subscript. Okay, subscript is below the line, superscript is above a line, almost like an exponent. Okay, so that 2, notice I didn't bring the plus, comes down and becomes a subscript on my chlorine. When that happens, the +2 goes away on the magnesium. Now the 1 from my chlorine comes down and it becomes a subscript here on my magnesium. And that means that the -1 goes away on my chlorine. What this does is it allows our charges to actually balance. Okay? So if you think about it before, I had my magnesium here with a +2 oxidation number, or 2 pluses. And now I have 2 chlorines, each with a negative. These cancel each other out, so my compound is actually neutral. So when I actually write I kind of scooch the symbols together. Okay, so I have 1 magnesium and 2 chlorines. So basically the idea is the number of the oxidation number of each element becomes the subscript of the other one. Now one other thing, and you know this already from other things you've seen, when the subscript is 1, it is typically not written, so we can actually take that 1 out of there. And the reason is, by just listing it, we know we only have one. It's not a zero. For instance, in this particular compound, I don't have any oxygen. I don't see oxygen symbol written, so we know that that one is a zero. So what do the formulas actually tell me? It tells me the number of atoms and the type of atoms and the particular elements that they belong to within my compound. So this one tells me I have one atom of magnesium and 2 atoms of chlorine that make it stable. Now we can also use the chemical formula to help us with the oxidation number of different transition metals. Okay, so remember, they are capable of forming different ions, like I showed you before with the oxidation numbers, but we can actually use these oxidation the formulas to help us determine it sometimes. So for instance, copper can form either +1 or +2. So let's take a look at this example, CuCl2. Now, since we did the crisscross method on this, we know that the 2 on the chlorine came from the copper. And we only have one copper, and that's because chlorine's oxidation number is always -1. So in this case, I can kind of take the subscripts and reverse them back up to superscripts, and I know the oxidation number on the copper is a +2. Now let's take a look at the covalent side of things. As with ionic compounds, we have to have the oxidation numbers balancing. Now, unlike the ionic compounds, let me show you one here. With ionic compounds, I do have to make sure that I simplify. So for instance, if I have calcium and oxygen here, and I crisscross them, my formula would be Ca2O2. Now, both of my subscripts are 2. And in ionic compounds, I actually want to have that be the simplest whole number ratio. So in this case, what I do, or the way I think of it, is I look at these 2 numbers and I say, can I simplify that? Almost like you would simplify a fraction in math. And in this case, the answer is yes. I can divide both of those numbers by 2, so actually my correct formula would simply be this. Ionic compounds do have to be written with that simplest ratio. I had forgotten that earlier, sorry. That is important. Okay, so the oxidation numbers have to balance, and so we use the crisscross method just like we did before. Now, in terms of what element gets written first, it's going to be the one that's going to have the positive oxidation number, so it's the one to the left followed by the one to the right. So in this case, we are doing a compound with hydrogen and oxygen, so we write hydrogen first and oxygen second. Then we need to write the oxidation number for each element as their superscript. Just keep in mind that they're actually not forming a charge here. It's how many they're willing to share. So in this case, it would be a +1 and a -2. And then we use the crisscross method to write the formula. So in this case, I would crisscross, and my formula should look familiar, and it is water. Now, unlike in ionic compounds, it does not have to be the simplest ratio. So for instance, if I have a carbon with a +4 oxidation number and oxygen with a -2, when I crisscross that, I would do C2O4, and I could leave it like that. And I have other examples, for instance, C2H8, and so forth. Okay, each of these are different. I don't have to simplify those. Even something that you guys have seen before. Now this involves 3, but I don't have to simplify that either. We don't do that with the covalently bonded compounds. Now, in our next lesson, what we're going to do is take a look at polyatomic formulas. So, but what you have is actually some practice with the binary, okay, the ones that only involve two elements, and that is actually a homework assignment for you.